Hey, welcome back to Programming with Puredata. Last time, in the last video, we were looking at this Puredata patch which we were designing to do something called Wave Field Synthesis, and we got it finished, or relatively finished, and it works. Um, the only issue with it is that I have to present it. I have to present it at the university as a piece of coursework, and during this presentation I'm going to have to get people to work with it and use it, and it's not very user friendly at the moment. If you remember, or if you were watching, basically if we put it into run mode, what you have to do is, to get it to work, you turn on your DSP there, and that lets you start doing your digital signal processing, and then you have to click on each of these bang objects to start loading files in. So we have to go in here and we have to look through all this, and once we've loaded all these files in, I have to press start, and then the audio will start, and we can set our delay time from here. We have to set this number here, send that and set it here, and it sets a delay for us. And then to do this bit we have to do something similar where we go like this, we set these numbers here, and then we send the message 1 here, and it'll divide, and then we'll do here, and then we'll get in decibels, and then we can put the audio up. Anyway, it's a bit fiddly, and it's very messy looking. It looks very messy, so we need to tidy it up a bit. And there's a whole bunch of ways that we can do this, but I think to make it as easy as possible for other people to use, we're probably going to use something called subpatching, which is a pretty useful thing that you can do inside of Puredata. Basically, you can create multiple canvases, which is basically what each of these windows is called. You can create a whole bunch of them, and you can link them together, and you can pass information between canvases. If you think of it as like a leveling system, where you have maybe one main canvas which is on the surface, which has the most basic user interfacing tools, and then on the level below that we feed all the information the user is providing. So we might feed the canvas below the main canvas a fader movement, and then what that'll do is it'll change the volume inside the canvas below the one that the user is interacting with. So to give you a rough idea, we'll just close this right now, and we'll create a new PD patch just really quickly. So we've got this one here, and we create this object, and we go PD, and we'll just call it add. There, and now we have this canvas called PD add, okay, and we can pass information to it by adding this object which is called an inlet, and you can see now that we've got an inlet here on this canvas, and we've got an inlet here. So what we would do is we might put a number box, and then we would link it to the inlet here, and then what we might do here in the add one is we would put a message box that says let's times it by 5, which I think should work. Sorry, is that a times? Yes, that should be a times symbol there. Right, and then what we would do is we would create an outlet object, outlet, link that to the outlet, and then create another number box down here for the answer to go into. So if we put that into run mode, yep, and then we start to feed this here. Put that in run mode 2. Okay, that message box isn't working. Basically, what we would do is we might have this, and then we'll feed it that, and what should happen now when we run this is to see what's happening here. So if we start here at 4, it comes into PD add through this inlet, gets sent to this message box here, this number box, which is 4, and then goes to the outlet. What we can do inside of here is we could have created another object and go one level deeper. So we could put PD and we'll just call it divide, and then we get another one. And what we could do here is put an inlet here and then send that into there, bring it into an object. This should divide the number by, let's say, 2. Give it an inlet there, and then we'll give it an outlet object. Connect that to there, and what we should get is an outlet here, but for some reason we don't have an outlet there. Where's that divide gone? Has that gone all the way back to here? There? No? Here. There's the outlet. Right. So now we've got the outlet. What we could do is feed it into there. And now when we run all these patches, what we should find is that we can... Oh no, wait, there's no outlet here. We need to make an outlet here as well to feed the information right back up to this top here. So we would take the outlet of this, shove it in there, and then take the outlet of this and put it in there, and then we run it. So let's run all of these. So what we should have here is the number 6. Put it at number 6 or 8 to keep it easy. So we've got the number 8 getting passed into this subpatch here, which takes the number 8 and passes it into this subpatch here, divides it by 2, and then the outlet of this subpatch brings it back in to this patch here, and then the outlet of this patch brings it right back up to the top with the answer. So you kind of get the basic idea. It gets kind of complicated when you're trying to do it with a larger scale program. So this is a really basic program where we've got an inlet, a user number, an inlet, a subpatch, and then another subpatch and an inlet which takes it to be divided, and then an outlet which goes up by 2 levels and gives you the answer here. So with that in mind, I have already made all the subpatching for our program, our Wave Field Synthesis program. It's called Wave Field Synthesis Clean. The reason I didn't make it on the camera is because it was very fiddly, and it's the first time that I've dealt with subpatches really, so I just did it off camera because I had to go backwards and forwards quite a lot. But you can see it's now much cleaner to navigate through. So this is the basically what we've got is this first page here, which is kind of the user interface. There's 3 sort of user interface pages. This is the first one, where you can load the files with 1 click and start the audio and stop the audio with 1 click, and you'll be able to see the levels of the audio coming out on these VU meters. This is the main kind of guts page. It's called Wave Field Synthesis Guts. Basically, this is where all the calculations are made and where all the sort of signal is dealt with, and it just feeds it back up to this patch here where you can see everything. So these other 2 patches here, we have one to set the delay, amplitude decay, sorry, this is the amplitude decay one, and everything's labelled really clearly so that it's really easy to use. And here's where we'll set our delays for our channels as well. So there's a couple of things that we need to look at here. First, we'll start with this sort of loading and starting system, because in the last PD video we had each channel had its own bang object to load files in, but with this we're just doing it with one bang. So we click on this bang, and it sends it to the inlet of Wave Field Synthesis guts, which is this inlet here. So this is the loading inlet. So this bang is sent to open objects. Well, there's eight open objects, one for each channel, and it's going to open these files. And the way that you do that is you go to Preferences and you set up a file path that will tell Puredata what file path to look in when you tell it to open something. So in the file path that I've specified in the Preferences area, there are all these files. So there's this one called Guitar2, Guitarist1, all these files are specified already. So this knows to go to that file in that file path and open it. And then what we've got on our user interface page is start audio, which is another bang which just sends this start. It basically tells the start message to send to the readsf object, which will start the audio. So I'll show you that quickly so that you can kind of understand it a bit better. So we'll have a look here and we'll go load files and start audio, and you can see that the audio has started playing. Whether or not you can actually hear it is another thing, because it's probably coming out of my speakers again. And then what we can do is we can click this bang to stop all the audio at the same time. We can only hear 2 channels of this though, because I've only got inputs 1 and 2. So it is sending to all the channels. I just don't have all of my speakers plugged in at the moment, which there is also a video of somewhere. So that looks much neater, and you don't have to fiddle around with stuff here. And really, you don't really have to use this page at all anymore. You'll notice that there's a couple of other subpatches. So there's the one to set the volume, where the user, it's exactly the same sort of part as was in the last video. The user just sets the distances, well, starting with the right because we've already made a mistake. So let's say it's 5, 25, and then they divide by 1, and the answer of that gets sent to the channel 1 inlet over here. And then, funnily enough, I've actually worked out how to set it to automatically adjust the volume. So you don't even have to change the fader anymore. Literally the user just has to set this calculation up for all of the faders. So let's say we've got a 6 as well. We'll send it 6 first, and then send it 6 again, and we should get 36, and then we'll divide it by 1, and then if we look at the channel 2 fader, there we go, it's gone up by the appropriate amount. So we would do that with all of them. And then when we want to set the delays as well, we come in here. This is our delays here, and we've got all the channels labeled as well, so you know which one you're sending your delay to. So you send your 340 message, and then you tell it to divide by something. And then if we look in the Wave Field Synthesis guts part, we should see that we've got 0.014 milliseconds of delay set onto this channel. So in that way, the user never really has to look at this guts page, because we know that these are all sending through their subpatches into the main page where all the calculations are taken out, and then fed back up to this page here where you can see the actual audio output. And it's really handy to have that, because although you've limited the choice of the files that you can load in, you still have that increased functionality whereby anyone could sort of use this, because the controls are so basic. So if we set it up so that we had something where it opened and it looked like this, if these channels were a bit closer together, and then you could have this here, and again the channels would be a bit closer together. And then you could have the other one. Where is it? This one. You could sit down here and stretch it along. There. And then it's all out for the person to use, and it looks good. You know, it's not like a really big, complicated, scary looking program where, you know, people are going to look at it and go, oh god, I don't know how to use this. It's really basic and it's really simple to use, and it looks cleaner than the program we had before, which was looking something like looked like, hang on, it's probably here. It looked like this. I mean, that just looks a bit like a mess, to be honest. You can't really see anything. You don't know what you're doing with it, really. So yeah, I just thought I'd show you it. It looks much better now. It, it runs a bit better because it's easier to use now. And the subpatching for it wasn't too difficult to subpatch all of it, but it was definitely quite fiddly in that I had to, well, for a start, I'd never subpatched before, but the kind of thing that you have to get your head around is making the subpatches from this page here, as opposed to making them from another page. So what we had to do was, on this page we had to put PD, well, we started with this page, I think, and I put in that and then copied the other program into this, and then started feeding information from this into here, and then from here we made the subpatches for the distance and delay calculations so that we could feed the information from this subpatch back into this one. Yeah, and that's it. It's a bit better looking, a bit easier to use. Still works. Probably works better than it did. I don't know if I've turned on my DSP. I haven't. Looks a bit better. It's a bit easier to use. And yeah, that's about it really. So thanks for watching, and yeah, that's it. Bye.